Okay, good morning to everybody. Today we'll start an important theorem, complex Cauchy's integral formula of complex integrations. This is a part of complex integration. We have to state and prove Cauchy's integral formula for analytic functions. Then you'll find that its derivative. Okay. Then evaluate the following Cauchy's integral. Evaluating the followings by Cauchy's integral formula. That means there are some questions. Actually, this is the closed integration. Okay, closed integration, and it is also called contour integration. Okay, so we'll try to solve this part now. Okay, today we'll start an important formula in complex integration, Cauchy's integral formula. Cauchy's integral formula. The statement will be let f of z be any analytic function inside and on a simple closed curve C taken in positive sense. That means this will be anti-clockwise. If A is any point inside C, suppose any point, this is the any point A, okay, inside C, then f of A at the functional value of at that point, f of A will be 1 by twice by this closed integration. That means contour integration of f of z divided by z minus a dz. Actually, z minus m is what? There are many values of z inside C. So the distance, the z minus m is the distance between any point of z and the point A. So this is the functional value f of A will be this, and this is actually called Cauchy's integral formula. Now I'll try to prove this formula. First of all, since f of z is analytic, this is f of z is analytic, and inside C, C is the actually closed curve, and A is any point, and f of z divided by z minus a is and also analytic except a, except z equals to a, because if z equals to a, then this will be something by 0, that means infinity. This is why except z equals to a, this is also also analytic function. So now if we draw another curve C1, if we draw another curve C1 with center at A, that means the center will be what? A. Okay, with center at A and radius will be R. Okay, so radius will be R. And C1 is interior of C. That means C1 lies inside C. So this is actually multiple integrals curve. So by for multiple connected region, multiple connected region, because from figure we see this for multiple connected region, because first the contour C1 and C2. So we get actually say this is the contour integration f of z divided by z minus a dz equals to, this is equals to another C1 of z divided by z minus a. Actually for multiple connected region we can write this from Cauchy's integral theorem. Now since z minus a equals to r, this is the z minus a, this is the circle from our figure, and radius is what? R. Radius r. So we can write this as a z minus a equals to r into e to the power I theta. That means in exponential form of complex number, where theta lies between twice pi. That means 360 degree. So from here z equals to, we can write a plus r into e to the power I theta, and dz equals to what will be? dz equals to differentiating with respect to theta I r e to the power I theta into d theta. Okay, I r e to the power theta d theta. So this is equation number 1. This is equation number 1. This comes from actually Cauchy's integral theorem for multiple connected region. Now just substituting these values, we get what? From equation 2, z minus a dz equals to, integral limit will be what? 0 to twice pi, and f of value will be what? F value a plus r e to the power I theta divided by z minus a will be what? R into e to the power I theta, and dz will be what? I r e to the power I theta d theta. So this equals to, actually we can write I into 0 to twice pi f of a plus r e to the power I theta d theta. Now if r tends to 0, that means radius, this is the radius, total radius r tends to 0, that means r minus a what will be? Distance between r minus a will be about to 0, about to a. So from this we can write, therefore integral limit f of z minus a dz equals to limit r tends to what? 0, I into 0 to twice by f of a plus ir theta equals to what? F of a plus r into I theta means what will be f of a. Okay, f of a r equals to 0. This is why we get f of a plus r into e to the power I theta d theta. So after this line, we can write this equals to limit. After putting the limit values, we get what? I into f of a. Okay, I into f of a 0 to twice by theta d theta. So 1 into this. Okay, this equals to I into f of a. This will be twice pi. Okay, one integration what will be theta. So after putting, we get this is therefore we get what? F of z by z minus a dz equals to what? Twice pi I f of a. Therefore, f of a equals to what will be? 1 by twice pi I contour integration f of z divided by z minus a
রাইট সাইডে কি লিখেছেন?
dz.
এটা ভিজিবল না, কেটে গেছে তো।
Right side this.
রাইট নাও, ওকে স্যার।
Okay, and this is the actually proof of this theorem. So this is the actually theorem. This is the statement, and fz must be analytic, and c is the closed curve c, and it is a circle of radius r. So and c1 is another circle inside c. So for multiple connected regions by Cauchy's integral theorem, we have already proved it in our previous lecture. So this is for multiple connected region. We can write this contour integration equals to contour integration of c1. Okay, same at same point and same center a. So you can substitute this circle z minus a equals to r, radius r. This is the circle equation. So dz equals to ir e to the power I theta d theta. Just substituting this, we can write this one and putting if r tends to 0, that means then taking limit r tends to 0, we get the values is actually what? A, f of a. Okay, so I of a and integration of 1 will be what? Theta. So the integration of 1 will be twice pi minus 0, upper limit minus lower limit. So we get the required result, and very easy theorem. So this is the actually Cauchy's integral formula at a point of a analytic function f of z at any point inside the curve C. Okay, A. So if we take differentiation, taking differentiation of this function with respect to A, we can write what? This 1 by twice pi I. So 1 by z minus a formula what will be? Minus 1 by z minus a whole square. Okay, for same contour integration, and this is the function z dz. with respect to a differentiation, what will be like this? It will be like this, okay? Understand? And this will be 1 factorial can be written as. And similarly, double differentiation will be what? 2 factorial divided by 2s pi I f of z divided by z minus a 2 plus 1. Okay. Can you write? In this way, the nth differentiation what will be? Nth differentiation with respect to a what will be? Factorial n divided by 2s pi I f of z divided by z minus a divided by n plus 1. Right? Understand everybody? And closed curve C. Remember it. So this is the main different derivatives of integral, Cauchy's integral formula. Understand everybody? Okay, now an example by using Cauchy's integral formula. You have to show that contour integration of the curve C e to the power thrice z divided by z minus pi I dz equals to what will be? There are two conditions. One will be minus twice pi I if C is the circle z minus 1 absolute value of z minus 1 equals to 4, and this value will be 0 if C is the ellipse. Okay, z minus 2 plus z absolute value of z minus 2 and absolute value of z plus 2 sum equals to what? 6. Actually, this is the equation of ellipse. Now solution. Here f of z equals to what? E to the power thrice z. Okay, is analytic inside C. Analytic inside C.
ব্লার হয়ে গেছে।
ব্লারি দেখাচ্ছে।
ব্লার দেখা যাচ্ছে। ঠিক আছে কিনা দেখো তো।
স্যার ক্যামেরার অটো ফোকাস অফ করে দেন, বারবার ব্লার হয়ে যায় মাঝে।
এটা অটো ফোকাসে আছে নাকি ক্যামেরা? এটা কিভাবে ইয়া করব? মোড়ে যাব না? না না মোড়ে না, এটা ক্যামেরার ভিতরে ঢুকতে হবে মনে হয়। হ্যাঁ, ক্যামেরার এখানে তো ঢোকা যাচ্ছে না এখন। আচ্ছা আপাতত এখন দেখা যাচ্ছে। আচ্ছা অটো ফোকাসটা বন্ধ করে দিতে হবে না?
না হয় ফোকাস লক করে দেন স্যার।
আচ্ছা আচ্ছা ওকে, আমি দেখি এটা নেক্সট থেকে করে দেব। Okay, f of z is the analytic inside and on the circle. What? Inside C on the circle z minus 1 absolute value of z minus 1 equals to 4. Also z minus pi I equals z equals to what? A equals to what here? Pi I. Okay, comparing with the our standard form or Cauchy's integral formula, and absolute value of this what will be? So absolute value of z equals to what will be? Absolute value of pi I, and this equals to pi, and this equals to 3.1416 approximately, which is less than 4 because the radius. That means this value lies, this a values lies inside C. Okay, lies inside C because if we draw the circle here, actually center will be what? 1,0. Okay, 1,0. This is the center of the circle. So if we draw a circle with this, so the radius will be what? 4. Radius 4, and this is the 1,0, and radius will be 4. So this point, a point lies in which? Inside the circle. Okay, inside the circle. Hence, so Therefore, z equals to pi I lies inside C. So by Cauchy's integral formula, we can write contour integration of C e to the power thrice z divided by z minus pi I equals to what will be? Twice pi I into what will be? F of a equals to pi I. Okay, a equals to what will be? A equals to pi I. This is why we are not writing f of a. So this can be written as twice pi I. This is f of z. Okay, f of z equals to what was? E to the power thrice z. So just putting z equals to pi I, we can write e to the power thrice pi I. 2 pi I. This is the exponential form. So we can write in polar form. How? E to the power pi, I x what? Cos x plus I sin x. Okay. Cos thrice pi plus I sin thrice pi. So twice pi I. This will be what? Cos 0 minus cos 0 degree plus I sin 0. And this will be minus 1. So minus twice pi I. And this is the, we have showed first one. If C is the circle inside the curve C, the value of this what will be? Minus twice pi I. Now for the second part, okay, now the second part of this, that means if this equals to 0, when it is an ellipse. Ellipse means what? Absolute value of z minus 2 plus absolute value of z plus 2 equals to 6. The center will be what? Minus 2, 0 and plus 2, 0. So, and this is the origin will be 0, 0. Here f of z equals to what? Actually e to the power thrice z divided by z minus pi I. And the equation of ellipse z plus 2 equals to 6. Okay, is the equation of ellipse uh, whose foci are because there are two focus whose so plural will be what? Foci. Foci will be what? Plus minus 2, 0. Okay, and length of the major axis will be what? 6. Length of the major axis will be 6. Since x equals to pi I lies inside C. That means 3 values will lie inside this one. This is the major axis, and this is the major axis, and this is the minor axis. So x equals to pi I, it is actually less than 4. So since major axis is 6, this is why you can say that x equals to pi I value, that means 3.1416 is less than 6. This is why this will lie inside this z equals to x equals to pi I, sorry, this not equals to z x, and this will be z equals to pi I lies not actually inside the C, outside C, because this is the minor axis. Okay, and this is the major. So 3.1416 lies outside the ellipse, outside C. So by Cauchy's integral theorem. Integral theorem. We must know from for outside we can write f of z equals to what? 0. Okay. Therefore, the curve f of z what was? E to the power thrice z divided by z minus a dz equals to 0. And this is the result for the second one. Okay. Okay, now the second example, we have to evaluate by using Cauchy's integral formula the contour integration for the curve C dz divided by z into z minus 4 whole square, where C is the circle, absolute value of z equals to 1. And this circle we can draw easily. This will be, and center will be what? Actually, I am not drawing well. This is the circle with center. This one. Okay, this is the x-axis and this is the y-axis. Center will be 0, 0. Okay, and radius will be what? 1. Radius will be 1. So solution for we get to for poles for z equals to 0 we get, and z equals to 4. There are two poles because at z equals to 0 and z equals to 4, this is the actually undefined. Okay, so this is are the called also singularity or poles. You must know from our previous lectures what is poles and this lie inside, sorry, inside C, and z equals to inside C and z equals to 4 lies outside C. Okay, C respectively. Z equals to 0 lies inside C and z equals to 4 outside C. Therefore, f of z equals to 1 by z minus 4 whole square. This is for the what? Outside. Which is analytic. Analytic inside on C. So this can be written as contour integration of the curve C dz z into z minus 4 whole square. Z minus 4 whole square equals to another contour integration f of z. F of z means what actually? 1 by z minus 4. Z minus 0 dz. So you have to remember that f of z equals to what was? 1 by z minus 4 whole square. So f of 0 what will be? F of 0, just putting z equals to 0 here, we get 1 by 16.
1 by 60, sir.
Okay, so just putting here, this is, you must know from the Cauchy's integral formula, this can be written as twice pi I into what? F of 0. Okay, so f of a means what? A means here 0. A means what? This one. A means 0. So twice pi I f of 0 what was? What? 1 by 16. This is why we can write pi I divided by what? Divided by 8. And this is the actually result. Okay, now same example, example 3, the contour integration of the curve C e to the power thrice z divided by z plus pi I dz, dz here, dz, where c is the circle z plus 1, absolute value of z plus 1 equals to 4. That means the radius will be 4. Okay, and center will be what? Center will be minus 1, 0. Here the center, the circle z plus 1, 4 has center minus 1, 0, and radius what will be? Radius equals to what? 4. But it has a pole. The pole will be what? Pole z equals to what? Minus pi I. Okay, so absolute value of z, that means minus pi I absolute value, equals to what will be? Equals to pi. Okay, equals to pi, equals to 3.1416 is less than 4 radius. So this lies inside C. Okay, inside the curve C, lies inside the circle C. So by Cauchy's, now let f of z equals to what? F of z e to the power thrice z. Okay, e to the power thrice z is analytic, inside on C. Okay, hence by Cauchy's integral formula, Cauchy's integral formula. Okay, I am writing in short. Cauchy's integral formula we have in contour integration of e to the power thrice z divided by z plus pi I dz equals to, can be written as equals to what? Twice pi I, equals to what will be? F of minus pi I, right? Because a equals to what? Minus pi I. Comparing with the Cauchy's integral formula, so you must know f of z equals to what? E to the power, f of z equals to what was? E to the power thrice z. So f of minus pi I, what will be? E to the power minus thrice pi I. Okay, so just putting here twice pi I, and the value will be what? E to the power minus thrice pi I. Okay, and twice pi I, and this is the exponential form of complex number. Another we can write polar form. So cos thrice pi minus I sine thrice pi. Okay, 2 pi I cos thrice pi equals to what? Minus 1, because in it is in third quadrant, pi. Which quadrant? You can select by quadrating, and the another one is 0. So we get minus twice pi I, and this is the result. Very easy example. All examples are easy here. ঠিক ব্লার হয়ে গেছে মনে হয়।
রুট 5 কোথায় পেয়েছি আমরা?
This is the circle. Just putting z equals to 0 here, we get the value of the radius. What will be? Root over 5. But this root over 5 is greater than 2. This is why for z equals to 0, z equals to 0 value lies outside the center. Okay, so this is the example 4, and where is the circle z minus 2 minus I equals to 2, and this circle has the center what? 2, 1. Okay, real part whole square and imaginary part whole square. If z equals to x plus iy, real part will be x minus 2 and y minus 1 equals to 2 square. This is why we get center 2, 1 and radius what? 2. And poles are will be what? Z equals to 0 and z equals to 2. That means at this point this function is not analytic. Since if we put z equals to 0 in the equation of circle in complex form, then we get radius value what? Root over 5. But this root over 5 is greater than 2. because 2 is the radius of the given circle. Since root over 5 is outside the circle, this is why for z equals to 0, this value is outside of C. Understand everybody? Outside C. So from the equation of circle, we observe that z equals to 0 is outside of the circle C, because the center lies in 2, 1. And if z equals to 2, then this from this equation we observe that this z equals to 2 lies inside C. Okay, inside the circle. Now so from this we can write here f of z can be taken as z plus 1 divided by z minus 2. Therefore, contour integration now by Cauchy's integral formula. Okay, I am writing in short form: z plus 1 z square z minus 2 dz equals to what will be this. This can be written as twice pi I f of 2, because a equals to 2. A equals to what? 2 at point 2. So f of z equals to what? Z plus 1 divided by z minus 2. Sorry, this will be z square. This is the z square. I am writing it wrong. And this will be z square at point 2. So f of 2 what will be below? 2 plus 1 divided by 2 square. This equals to what?
3 by 2.
3 by 4.
4.
So from here we can write f of 2 equals to what? Twice pi I 3 by 4. That means 3 by 2 pi I. This is the result. Very easy. All examples are same. Understand everybody?
ভ্যালুগুলোর কারণে আমার ফাংশনটা আনডিফাইন্ড হয়ে যাবে।
Okay, thank you. Now the another example 5, we have to evaluate the contour integration of the curve C, and C is the circle, absolute value z equals to 3 by 2, and the function is f cos pi z square divided by z minus 1 and z minus 2. So this circle has the center 0, 0, and radius will be what? 3 by 2. So poles will be what? At z equals to 1 and z equals to 2. This is actually not analytic. So just if z equals to 1 from here, if z equals to 1, that means 1 will be, if we take 1, then this will be outside or inside? Inside. Okay, z equals to 0 is inside the circle C, right? And if z equals to 2, then absolute value of 2 what will be? From this circle, just putting z equals to 2, and 2 lies what? Outside the lies outside C, right? Understand? Understand everybody?
জি স্যার
Because this is less than 3 by 2 and this is greater than 3 by 2. This is why lies outside. This is inside and this is the outside, because 2 is more and more bigger than the radius. So f of z can be taken as, so here a equals to what will be? A equals to 1. because one inside C, because A will be always inside, and f of z will be function what? Cos cos pi z square divided by what will be? Z minus 2. Okay, z minus 2. And so from here we can write actually cos pi z square divided by what will be? Z minus 2. Now the value of f of 1 what will be? From here f of 1. So if the f of z, then cos this integration cos pi z square divided by z minus 1 z minus 2 will be, this will be what? F of 1 by Cauchy's integral formula. F of 1 what will be? Is that equals to 1 cos pi divided by minus 1, right? Cos pi divided by minus 1. Cos pi equals to what? Another minus 1. This is one minus 1 what will be? Only 1. Understand everybody? So from here we can write twice pi I. F of 1 equals to what? Only 1. This is why our required value of the complex integration will be what? Twice pi I. Very easy example. Okay, now another example, example number 6. We have to find out this in a contour integration. This is the closed contour integration of closed curve C. And C is the circle. Actually, there are two types of circle for this integration. First one is z plus 1 plus I equals to 2. And second one is z plus 1 minus I equals to 2. Now for the first one, the solution is for the z circle z plus 1 plus I equals to 2, we get the center is actually minus 1 1, and the radius will be what? Radius will be 2. So we have to find out the poles now. We have to find out the poles first of all. So the center the radius is 2 and center is minus 1 1. This is the x-axis and y axis. So the graph of this circle will be this. Now for poles z twice z plus 5 equals to 0. Okay, solve this by using quadratic equation formula. Do you know what is quadratic equation formula? Comparing with the x square plus bx plus c equals to 0, we can find out the value of z. Minus 2 plus minus square root minus 4ac divided by what will be? Twice. And this value, there are two values. One is minus 2 plus minus 4i divided by 2. Okay, so there are two values, and we can write also this minus 1 plus minus twice I, right? So there are two values of z. One is minus 1 plus twice I, and another is minus 1 minus twice I. So there are two values of z. If z equals to minus 1 plus twice I, then we have to test whether it is inside C or outside C. So these two values are the actually poles of this circle. So if z equals to this, then from the equation of circle, just putting minus 1 plus twice I plus 1 plus I. This from this equation we can write what? Minus 1 will be cancelled, twice I plus I what will be? Thrice I. Okay, this equals to what? Only 3, and this is the greater than 2. That means greater than the circle. Understand? So z equals to minus 1 plus twice I lies outside outside C, right? Lies outside C. Understand everybody? Now, if another value of Z -1 minus twice I, then -1 minus twice I plus 1 plus I from this, just putting value of Z here. So this equals to what will be? 1 will be cancelled. Minus I minus twice I minus I. So minus I absolute value what? Only 1. And this is the less than 2. That means these values inside the circle C. So Z equals to -1 minus twice I lies inside C. Understand? Inside C. I hope everybody understand this. Inside C. Now from now consider f of Z equals to what will be? F of Z equals to, we have to consider what? F of Z equals to Z plus 4 divided by Z plus 4 divided by Z minus Z1. This means this first value. Okay, because this it has what? Two types of values, two poles, and Z minus this -1 means what? Minus plus minus twice I. Understand everybody? Just putting the first values. Okay. And A equals to what will be? A equals to -1 minus twice I. Remember it. So now by Cauchy's integral formula, we get what? Contour integration of Z plus 4 divided by Z square plus twice Z plus 5 dz equals to what will be? Twice pi I f of A, right? F of A. Twice pi f of A means what? F of -1 minus twice I. Here f of Z equals to what was? F of Z equals to Z plus 4 divided by Z plus 1 minus twice I. So f of Z minus -1 minus twice I, what will be? -1 minus twice I plus 4 divided by -1 minus twice I plus 1 minus twice I. This value what will be actually? This is always 3 minus twice I, right? 3 minus twice I. 3 minus twice I divided by what will be? 1 will be cancelled. Minus 2I what will be? Minus 4I. Understand? Minus 4I. So just putting here the values from here, twice pi I multiply 3 minus twice I divided by minus 4I. Minus minus cancelled, and 4 also, 4 and 2 will be cut by this. So we get only what? Pi by 2, and I will be also cancelled. So we get 2I minus 3. Okay, 2I minus 3. This is the result. Understand everybody? Hello? Understand?
Yes, sir.
Very easy example, but there are two complex roots. Finding the value of Z, it is complex root. This is why a complexity. Okay, now another second part of this. This is the second part. The circle equation Z plus 1 minus I equals to 2. That means it has same center and same radius. So Z plus 1 minus I equals to 2 has the same center minus 1 1 and radius 2, and poles will be same. Okay, minus 1 plus minus twice I, that means first pole is minus 1 plus twice I and second one is minus 2 minus 1 plus minus twice I. So just putting these poles in the equation of circle, we get that the value 1 greater than, sorry, 1 is less than 2, remember it. So that means this z value lies inside C, understand, because 1 is less than 2. Similarly, for the second poles, if we put the value of z here, then we get minus absolute value of minus thrice I. That means this 3 is greater than what? 2. That means this z values lies outside the C, because the value is greater than what? Radius. Now we have to consider the function for the at what? Z minus 2, at z2, then z minus z2, z plus 4 divided by z minus, there are two values. Okay, one value is what? Minus 1 plus twice I, another value of z what? Minus 1 minus twice I. So we have to consider the function z minus z2, because this z2 is the outside. Okay, this z2 what? Outside the circle. This is why this f of z value will be this, and a value what will be? uh, Value of z which is inside C. Okay, value of z, a value will be what? Which value of a which lies inside C. And so the by Cauchy's integral formula we can write z square plus twice z plus 5 what will be, and a will be what? A will be plus twice I, understand, plus twice I. So this values f of z2 will be plus 1 plus twice I. So
minus 1
we get actually this will be
z minus 1 plus 2 I হবে না?
plus
আচ্ছা ঠিক আছে স্যার।
plus minus 1 plus twice I. That means
তাহলে
we
স্যার
get only 3 plus twice I. Okay, 3 plus twice I, and here we get what? Z value plus twice I will be cancelled. So we get actually this is also plus twice I. So we get only 4i, understand. So this will be 4i and 3 plus twice I values. So this will be twice I plus 3, understand.
z2
So we get the value is 3 plus twice I. Okay, 3 plus twice I divided by 4i, and 2 will be cancelled, I will be cancelled. So we get only 3 by 2, 3 plus twice I, and this is the result. Okay, very easy. Understand everybody? This all will be plus, and this is also plus, this is also plus. Okay,
তো নিচে আই ক্যান্সেল হয়ে যাওয়ার কথা না?
yes, I cancel.
না স্যার ওইটা না স্যার, এফ অফ আমরা যখন মাইনাস 1 মাইনাস টুয়াইস এ বসাইছি নিচে,
Minus 1 1 will be cancelled, twice I plus twice I what will be? Only 4i.
তো জেড এর মান আমরা বসিয়েছি কত? মাইনাস 1 মাইনাস টুয়াইস আই না স্যার?
Minus 1 plus twice I, minus 1 minus na plus.
ও আচ্ছা
This is the a value, minus 1 plus twice I, f of a. Okay,
ওকে।
okay, now another interesting example. We have to evaluate the contour integration sin pi z square plus cos pi z square divided by z minus 1 into z minus 2 dz, where C is the circle, this absolute value of z equals to 3, and there are two poles you must know from here. At z equals to 1 and z equals to 2, the function except these two, this function is analytic. So we have to find out the poles first. The circle z absolute value of z equals to 3 has center 0 0, and radius will be what? 3. So this is the 0 0, and the radius is 3. Now the circle If for the first value, if z equals to what 1, then this value equals to 1 value equals to what 1. It is less than 3. That means lies inside C. Okay, and if z equals to 2, then z equals to 2 less than also 3 lies inside C. That means 2 values lies inside C. Understand everybody? So if f of z equals to what? Sine pi z square plus cos pi z square. If we consider this, then by Cauchy's integral formula, we can write by Cauchy's integral formula. Now by Cauchy's integral formula, we can write contour integration of C sine pi z square plus cos pi z square divided by z minus 1 z minus 2 dz. This can be written as by partial fraction. We can write like this. Z minus 2 minus z minus 1. F of z divided by z minus 1 z minus 2. Can we write? This can be written as what? Contour integration f of z divided by what will be? Z minus 1 this will be plus, and here we can take minus. Okay, minus plus f of z divided by z minus 2. Dz by partial fraction. Okay, z will be cancelled, and plus 2 minus 1 what? Only 1. This is why this f of z and f of z same, z minus 1. So just by partial fraction, we can write this. So this can be written as here minus f of z divided by z minus 1 dz plus contour integration c f of z divided by z minus 2 dz. So this can be written as by Cauchy's integral formula twice pi I. Here will be minus what will be f of 1, okay, plus twice pi I. Here will be what? F of 2. Understand everybody? This equals to minus twice pi I. F of 1 equals to what? Just using z equals to 1. Sin pi plus cos pi equals to what? F of z equals to sin pi z plus cos pi z square. This will be z square. So f of 1 what will be? Sin pi plus cos pi equals to what will be? Minus 1, right? Understand? And f of 2 what will be? Sin 4 pi plus cos 4 pi. Okay, this equals to what will be? Also 1. Just use calculator. So this multiply what will be? Minus 1 plus twice pi I multiply what will be 1. That means twice pi I plus twice pi I. This equals to 4 pi I. Understand everybody?
Yes, sir.
So z equals to we can consider here 1 and here 2. Okay, this value, two values are inside C. This is why we have to use partial fraction. Okay, for two individual poles, two individual value of z. Now the example 8, contour integration of 1 by z plus 1 whole square to z minus 2 dz, where C is the circle, the absolute value of z equals to 3 by 2. That means radius 3 by 2 and center will be 0, 0. Okay, so the poles are z equals to minus 1 and z equals to 2. The circle, the 3 by 2 has center 0, 0 and radius what will be 3 by 2. So if z equals to minus 1, okay, z equals to minus 1, then this value lies what inside 3 by 2. Okay, inside the circle. Now for z equals to 2, two values will be what? Two value will be greater than 3 by 2. Lies outside the C. Okay, outside the C. Remember it. So for z equals to 2, we get the value actually outside the circle. Understand everybody? So here actually we can take f of z equals to, here f of z equals to can be taken as 1 by z minus 2. Okay, and a equals to what will be? A equals to these values for which inside C minus 1, inside values of z. So a, now by Cauchy's, by Cauchy's integral formula, by Cauchy's integral formula, we can write the contour integration of C dz divided by z plus 1 whole square z minus 2 equals to twice pi I. What will be f of a? A equals to what actually? A equals to minus 1 and f of z equals to what? 1 by z minus 2. So f of 1 what will be? Minus 1 what will be? Minus 1 minus 2. So we get minus 3. So we get the result what? Here we have to find another one, and f of dash z, z minus f of dash a equals to 1 by z minus a, z minus a whole, z plus 1 whole square. Okay, z plus 1 whole square, f dash z. So for this f of z, f dash z equals to what will be this? Now f dash z at z equals to what? Minus 1. Z equals to z minus 2 at equals to 2. Integration will be 2. Minus 2. So f dash minus 1 will be what? 1 by 9. Understand? 1 by 9. So this can be written as, by Cauchy's integral formula, you can write twice pi I multiply f of minus 1. Twice pi I multiply what will be? 1 by 9. And this will be minus, there will be minus 1 by 9, minus 1 by 9. So we get minus 2 by 9 pi I. Actually, there is a, we have to use derivative form of Cauchy's integral formula for that. Derivative, because there are z plus 1 whole square. Okay, so since a equals to minus 1 is inside C and z equals to 2 is the outside C, so we have to take the derivative of this. Okay, f of z equals to what? 1 by z minus s. So derivative what will be? Derivative of this minus 1 by z minus 2 whole square. Okay, so we have to find the value of uh, derivatives at a equals to minus 1, which is inside C. Okay, then we get minus 1 by 9. Just this is the formula, minus twice pi I f of minus 1. This is the result. Similarly, we can find the example 9 also similar process, and example 9 also similar process, and example 10 also. Okay, this is the example 9. We have to evaluate 1 by twice pi I contour integration of z into e to the power z divided by z minus a whole cube dz, where a lies inside C. Okay, C is the any curve, C will be any curve, and a will lies inside C. Then you have to find out these values. We must know from the Cauchy's integral formula for higher derivatives, f of nth derivatives of the analytic function f of z at a equals to factorial n divided by twice pi I contour integration f of z divided by z minus I whole to the power n plus 1. This is the formula for higher derivatives. So from this we can write contour integration f of z divided by z minus a whole to the power n plus 1 equals to, can be written as twice pi I divided by n factorial f of n a. Okay, and this can be written as also twice pi I divided by factorial n, and this is the nth derivatives with respect to z. Okay, and this is equation number 1. For this we have to use this formula, and this will be at z equals to a. Remember it, where a is the is a point inside what? Inside C. Now for the given integrals, we can write the contour integration of z into e to the power z divided by z minus a whole cube dz equals to what will be? What will be here? A equals to what? Twice pi I divided by 2 factorial, and n equals to what will be? F of z. Okay, at z equals to what? 2, because comparing we get z equals to 2, and f of z what? F of z equals to what? Twice pi I 2 factorial, f of z is z into e to the power z. Okay, double differentiation of z into e to the power z at z equals to what? 2. At z equals to The first differentiation, just UV process with respect to z, what will be? Twice pi I divided by factorial 2. First derivative, what will be? U into differentiation of p plus b into differentiation 1. That means we get this one, d dz at z equals to 2. Understand? Now again differentiation, twice pi I divided by factorial 2. Again differentiation, what will be? Z into e to the power z, also z plus 1 into e to the power z, plus again e to the power z formula. So we get what? Like this, z plus 1 into e to the power z, e to the power z formula, e to the power z. At z equals to what? 2. But second, here we are given point what? A. So we have to consider at z equals to A, because we are already pool A. Understand? This A. So twice pi I divided by 2, just putting z equals to A, what will be the values? A plus 1 e to the power A e to the power A. Okay, that means twice pi I divided by 2 A plus 2 e to the power A. Hence, value of this will be what? 1 by twice pi I z e to the power z divided by z minus A whole cube. Dz what will be? We must know these values. What? 1 by twice pi I multiply these values what? Twice pi I divided by 2 A plus 2 e to the power A. So we get the required result what? Twice pi I will be cancelled. So we get only half A plus 2, half A plus 2 into e to the power A. Okay, this is the required result. Very easy example. Using the derivatives of Cauchy's integral formula, we have proved this result. Okay, now the last example of this part, 10, show that the contour integration e to the power c twice z e to the power twice z divided by z plus 1 to the power 4 equals to this 8 pi I e to the power minus 2 divided by 3, where c is the inside the circle, absolute value of z equals to 3. That means radius is 3 and center will be what? 0, 0. Same procedure we know from Cauchy's integral formula for higher derivatives. F of nth derivatives of the analytic function f of z at a equals to factorial n divided by twice pi I contour integration f of z divided by z minus a n plus 1 dz. Okay, so this equals to twice pi I factorial n nth derivative at a. So this can be written as, this is equation number 1, at z equals to a. Remember it. Here a equals to what? A equals to minus 1. Remember it. Here a equals to minus 1. Here a equals to minus 1 and f of z equals to what will be? Here a equals to minus 1 and f of z equals to what will be? F of z e to the power twice z. Understand? This is the difference.
Minus 1, sir, equals to.
Sorry, minus 1, right? A equals to minus 1 and z equal f of z will be, function will be what? E to the power z.
It is equal to 2, sir.
E to the power twice z, right? Is an lighting in the circle z. So the counter integration at z plus 1 to the power 4 e to the power twice z, this values what will be twice pi I, and here 4, n equals to what? 4. So you get what this what will be 3 factorial, right? 3 factorial. Understand? This will be 3 factorial, and derivatives will be how many times? Here n equals to what will be 3. This is
স্যার
why
এখানে পাওয়ার 4 না,
no.
z plus 1 whole to the power 4.
Power will be 3.
That
Okay.
means 4 minus 1 factorial.
4 highest power 4 what? 4 means what? 4 means 3 plus 1. 3 plus 1. Understand? N equals to 3 here.
Okay.
Okay. This is why factorial 3, and third derivative of f of z. F of z equals to what? What actually? E to the power twice z. Understand? At z equals to what will be? Minus 1, because pole is minus 1. So this is the 3 factorial. 3 factorial.
Z equals to minus 1.
And this is the third time derivatives. So this can be written as twice pi I divided by 3 factorial. This will be 3 factorial. Remember it. Just comparing with this equation 1. Here 4 plus 1 means what? 3 plus 1. Okay, this is why we get the first derivative what will be 2 into e to the power twice z, right? And we get d square d z square this. At z equals to what will be minus 1. So after this line twice pi I divided by factorial 3, another derivatives what will be? Another derivatives what will be? 4 e to the power twice z. Understand? Z equals to minus 1. So this equals to twice pi I divided by 3 factorial. So last derivative 8 e to the power twice z at what? Z equals to minus 1. Twice pi I divided by 6. 3 factorial means what? 6. And after putting z equals to minus 1, what we get? What we get? Z equals to minus 1. We get 8 e to the power minus 2, right? 8. And this equals to what actually? After we get 3. So 8 pi I e to the power minus 2 divided by 3. So we got actually this integration e to the power twice z divided by z plus 1 to the power 4, z equals to this. Understand? Short. Very easy example, just using the derivatives of contour, derivatives of what? Cauchy's integral formula. Very easy. Understand everybody? This is the nth derivative formula. Very easy.
Okay, sir.
Okay, thanks to everybody. Bye bye.
Practice because I
জি স্যার, ভালো থাকবেন স্যার। আসসালামু আলাইকুম।
Okay, best wishes for you. Bye for today. Assalamu alaikum.
জি স্যার, আসসালামু আলাইকুম ওয়া রাহমাতুল্লাহ।